What's up, guys? My name is Khan, and we're back today with more Scrap Mechanic, and today we're back in the piston-powered challenge. We are going to beat this torque test with a legit piston engine. I think I've learned some things. I also realized you guys made a few comments in the last video. The locks I put on the piston engine were the wrong way. You have to have the locks from the unloaded side to the loaded side, and I had them the other way around, which means when you actually applied a significant load to the engine, the locks wouldn't do anything. So anyway, we're gonna try and make a piston engine that can do this challenge. I'm just gonna make it a 4-piston engine because I feel like based on the torque readings we had, 4 was more than enough. And just to make it extra spicy, we'll put a Tremel gear on it and do a 2-to-1 reduction. So we'll spin it twice to get this thing moving, and that should just apply a ton of torque, and we should be good to go. So we're gonna grab all our bearings, 10 pistons. See, this challenge only has 10 pistons. Right? Like, I only see 10 pistons. Anyway, the nice thing about this challenge, there are 9 challenges. There's 3 torque challenges, 3 speed challenges, and then 3 hill climbs. But if we press this yellow button, we can actually skip to the next challenge without having to do it. So we can unlock all the challenges and do whichever one we want. So I'll probably switch it up after this one and maybe do like a speed challenge or something, and not just do torque over and over again. But you know, we'll see what happens. Let me know what you guys think in the comments down below, which challenges you want to see. But yeah, we're gonna build ourselves an engine with a relatively large crank, and I want to make sure that like we've got a pretty large distance on the pistons here. So we're just gonna start again, probably from like the front. It really doesn't matter, and we're just gonna do the old standard setup. I like challenge mode, don't get me wrong. I like inventory and scrap mechanic. I wish stack size was infinite. I don't like the fact that the bearings are such a small stack size. But anyway, we're gonna do this, 4 pistons. Boom, we're gonna space these out just because it's, you know, easy enough to do, like so. And then of course we're gonna do another one here and one more. We could go to 8 pistons. I'm gonna just keep it with 4 because I think like that should be more than enough. If we have them on max power and we've got a relatively large diameter on the shaft, then you know they should have no problems powering through it. So we're gonna go 1, 2, and then attach it to the shaft, and this will give us just an absolutely, oh no, I'm an idiot. That's right, you have to, no, I'm sorry, I'm making mistakes already. That's right, we gotta go like this. There we go, we put them here. Yeah, there, we want the pistons. The crank itself has to have the extra distance, not the pistons. At some point in time, I wanna make a real piston engine, which I haven't ever done in Scrap Mechanic. I don't know if I've ever seen one, but in Scrap Mechanic we do this where we've got bearings on the top, bearings on the bottom, so the piston can like angle back and forth. But real life car engines don't do that. Your piston stays up and down, and you have an extra little connecting rod there that actually controls the angle back and forth. And it would be interesting to try and make an engine like that in Scrap Mechanic and see what happens. I've never actually done it, so I have no idea, but it would be kind of cool. Anyway, so this is gonna be the distance there to our shaft. We could go 1 extra one, but I feel like that's more than enough. I'm gonna make this out of a square so we can easily just put the locks on it, no issue. So we're gonna go like that, square, like that, square, and then like that, and one more there, and just like that, perfect. And we'll just weld all these up. And that way we can, of course, make the lock mechanism once we've got the whole thing going. And then we'll do this, of course, and put the encoder wheel on this side. So this will be our unloaded side, which is also going to be the side that's mounted to the frame. And then the other side will be the loaded side. All right, so now we just got to set up the controller settings for this thing. And then, of course, we got to build the piece that actually is going to get into that. I hope we have the ground clear. Oh, I didn't think of that. We have to key into this. The Tremel gear does go down a block. I don't know if we're too high up. I think we're 1 block too high. Yeah, we're a block too high. So we can Tremel it down 1 block because the Tremel moves 1 block in either direction, like it moves the shaft. This is gonna have to come down by 1. And now hopefully we still have the ground clearance we need with this. We should, I would assume, but here we go. Let's put this down. The controller. We're going to attach this to here to offset that, and that. These 3 are 90s. And then, of course, we're going to have to put the locks in place. And do I AND gate these sensors so we can turn it off? Yeah, I think so, because we have to be able to turn it off and on to get it to jam into that thing. Wait, why do I have 8 sensors. Oh my god, what am I doing? Why am I building an 8? We're not built. What is this? I don't need 8. Okay. Jeez, I was wondering what I'm so used to building all these magnet engines all the time. That's the freaking problem. There we go. That's pretty smooth. And now we can, of course, speed them all up just to maximize the... Okay, maybe we can't. Uh-oh, this might... We have to have them at max speed. Oh, there we go. It just needed to have them all. Okay, that looks pretty good. I mean, that's very... It's a little bouncy. I wonder if I adjust this. Nope, that's the wrong direction. Let's go back this way. Oh, that is also terrible. Okay, let's go back to 0. I mean, it looks good. I'll give it that. I think if we put a tremolo off this to bring it down an extra block, like that's got a lot of torque. It's only gonna spin twice. Now, unfortunately, in this case, I don't see a way to avoid having to do a through bearing here. I think like there's the tremolo portion. I think we're gonna have to do like this and then have, you know, a block that comes off on this side and a block that comes off on this side and extend the axle through this using a no-clip piston. I don't see another way to get this mounted without causing some serious problems otherwise. Like if we do this and then we do that, that'll carry through. I know this is really bad for resistance though, but the tremolo has to be mounted to its own like axle point. It can't extend off this because it goes down one block. So I'm pretty sure that's just what we're gonna have to do. And then of course we weld this. Oh, whoops, this has to be vertical, my bad. But we weld this in there. There we go. And then we can put this back and attach this to here. Right? And that should work fine. Yeah, it does. The engine has a bit of a skip, which I'm not a fan of. I also put it so that these don't activate until we turn on the engine, so it doesn't try to rotate the shaft into position until the engine's turned on, which might be bad, but I'm thinking that if we do it that way, then at least the, you know, this will stay straight so we can line it up into that piece. Like, I don't know if this is gonna be good or not. Let's, you know what, we're almost there though. Let's just do like maybe a 15-degree offset on this. Ooh, that seems to smooth it out a little bit. There's a lack of support here, which causes this to kind of, like, the tremolo to kind of bounce around. I don't know how much that's gonna matter. Like, when we did the tests on the dyno, adding the extra support layer made it worse. It made the torque, like, you lost more torque. But I think this will be fine. All those are lined up. They all lock into place. If we put this back on the lift, yeah, they all open up. All right. Everything's connected. Tremolo's in place. These are all back on max speed because that also generates max torque. Theoretically, the engine's gonna spin twice and this whole wheel's gonna spin. And if not, I don't know what to do. Starting the timer. Okay, well, it torqued itself right out of position. I didn't really want to do this because I'm pretty sure this isn't like super efficient, but I don't see a choice because the tremolo, as soon as you applied too much load, it just bounced right out of position, and that's not helping anything. So I think this is the solution to doing that. I'm gonna have to just get up there real quick. Oh. Do I lose those parts of the void? Can I reset? Do I get those parts back? Oh, I do, thank goodness. They just got yeeted. That would have really sucked to lose those parts of the void. It's like I really, really need those toilet paper rolls and I don't have extras. Oh man, that would have been rough. Oh, actually, I can just I can clean. Like, whoops, didn't want to do any of that. Okay, perfect. We're in a good spot. Yeah, no, I can clean this up a little bit. We'll do this. Put this here, like so, and then we're going to grab this piece and put this on that. Gotta just sort of put this whole thing back on a lift. I'm not overly enthusiastic about the results of the first time. By the way, this is the easy torque challenge. Like, you know, I'm not even onto the harder ones yet where the wheel gets heavier, but I feel like there were just some design flaws with this setup. And so I feel like this is gonna reinforce it a little bit, hopefully. But yeah, I'm not really confident in any way right now. I'm kind of concerned that this is just gonna all fail quite horribly. But anyway, let's just do that. That gets attached to that. All right, so that's it. So now we should be good. We've got a connection point here into the Dremel, so that should keep that supported. This goes. All right, let's line her up. Try it again. I mean, I don't know. I'm curious if I were to take this and put this on the dyno, what it would actually give us. All right, think that's lined up. Yeah, perfect. Just push that in. Okay. All right. Hit the green button. And start the engine. Oh my god, it's doing it. Look at it go. I mean, it's gonna jerk back and forth, but look at it go. It's actually... Don't stall out. Oh my god, look at the torque on this thing though. Like, that's insane. That's insane. Come on. Spin. Okay, we're moving better than we did the first time we tried this challenge. I will say, the locks seem to be working. I feel like the encoder wheel is a little bit, like, oh my god. Let's, like, just torque through that, man. If I had 8 cylinders, it would probably be better. It feels like this is just gonna pop right out, which it definitely is. Oh my god, like, what the heck? We're actually gonna slide this engine out, and then it's gonna explode. Well, that's not good. How do I... Oh, you know what? Yeah, it just... Okay, you know what I need? I need to put a piston on the back here that pushes up against this and just pushes us forward. Because right now we're sliding away from the thing. It was turning, though. It was turning. We were in a good spot. Now we should be able to get this done. Oh, I really hope this works. Here we go. Yeah, there we go. Just torque right through that. Oh my god. Everything feels like it's gonna just explode. Like, it's doing it. I really need to rebuild this engine now in creative mode, which maybe we'll do sometime, and rebuild it with this kind of same dimensions and with the same Dremel and see what the torque output on this shaft actually is. But it's like, it's working. That's gonna slide up and over. Are you serious? If that slides up and over and off the barrier, then this is gonna slide back out again. We're almost at a quarter turn. There we go, it got something. Oh, the lock jammed through. The lock actually just pushed right through. It just snapped through that point, okay. So we might need to make the locks out of a little bit, actually out of like a bigger block. I don't wanna make them out of blocks though, because blocks have like different hitboxes. Maybe we can make them into logic blocks, and they'd have better hitboxes. Timing on this seems kind of wonked. What if I put another... We want them on half the time, off half the time, which is what we got. What if I rotate... Oh, I can't change stuff. That's right, I can't change the settings. Yeah, no, that flew right off. We gotta build a bigger wall on that thing. Now we're just gonna get jammed out again. How far do we even, like, we rotated, like, where's the blue marker? Oh, the white marker's there. We got a quarter turn. I feel like this is the strongest, like, that's gonna hold it down. We've got weight. We've got torque. Oh my god. Come on. Come on now. These are all maxed out. Yeah, look at the lock. Okay. I feel like we almost have to like double or triple trammel it, but it's just, you're more collisions, you know, and it's more collisions in Scrap Mechanic I feel like is bad. Or I just need more cylinders on this, like maybe if I did 8. But I'm using all the rest of the pistons for stuff. There's only 10 pistons in this challenge for some reason. I could have sworn though when I beat it there were 20, but there's only 10, so there's nothing left in the box. How are you doing? Oh, this is the lock mechanism's helping. Oh, this is torquing against the sign. That's ridiculous. We're a quarter of the way there. Perfect. This is an actual piston engine though. Like this is no nonsense. This isn't some weird, I did the weird ratchet mechanism thing before. No, we're piston engineing this 100%. But the engine is it's not having a good time. It can't get that smooth rotation going. I don't know if that's because my timing is slightly off. I'm gonna fix the lock by taking the bottom lock piece and putting it as a logic block. So these ones will be, I know this is really gross. And then I also wanna play around with this timing a little bit. I feel like we could advance the timing. Like if I put it 15 degrees forward, yeah, that advances the timing a little bit. I think that's gonna help. Because I think if it's 15 degree forward, then we need the extra piston to fire a little bit earlier. This comes down to that, again, this is that problem we had with the, whoops, oh no, not good. This is that problem we had with the magnet helicopter. The timing, once you loaded the propellers and you put the propellers on the engine, the timing had to change, and it wasn't the same timing when it was running no load versus when it was running with load, which is interesting. And I actually had a few people in the comments suggest that you make a dynamic timing mechanism that as your engine speeds up, the timing changes, which, like, you know, without mods, I have no idea how you even begin to do that. Because you basically need the controller to rotate it changes this controller angle based on how fast you're spinning, which, like, I don't even know where to begin on that one. But here we go. That's that. We're hooked in. Got better locks now, and I've got a 15 degree on this timing when we turn it on. So I'm thinking that'll help. Just helps activate the next piston a little bit earlier, which I think will help push us through the positions. I think the logic block locks will help us not jam the pipes through them. Oh, it's activating. No, now they're activating too early. This needs to be slower. Look, this piston's fighting, like it's turning on and pushing it back. Yeah, okay. This is it's the wrong way. Timing has to go this way. Maybe. I don't know. Let's find out. We're just doing some guess and check work now. And I feel like we'll eventually get the solution. But yeah, it was activating the other piston before it had crossed the point. There we go. There we go. Now it's got two pistons active, solid. And then this one should activate, like, soon. Should have activated already. We almost need this just a little bit. See, now it hands it off to a second piston. Yeah. I need that one to activate just, okay, so the timing's just, it's all in the timing. The timing is just slightly off. This needs to be like -30. Maybe even like -20. But let's go with -30. Yeah, it had two pistons solid, and then that one came on, and like we were opposing the pistons with the other one. It's crazy how critical the timing is. I mean, it makes sense. It's, you know, it's the same with your car. If you don't have the proper timing, it misfires, but like, there we go. So it's got two. Oh, I didn't activate the green light. Burp derp. Yeah, the spud gun breaks the wheel free. Otherwise, I was spinning against a wheel that can't spin. All right, when does this one come on? Yeah, perfect. It needs to come on right when it crosses the plus line, and then this one needs to turn off right when it crosses that line as well, the vertical line, which it does. Okay, so 30 degrees seems to be better time. We're moving now. Yeah, look, the third one wants to come on right when it crosses the line, right when this one wants to come off. Come on. Oh, it's coming on a little early. A little bit early, but that's okay. Are we almost through one rotation? We can't get the momentum built up to get the wheel that... Maybe if we could get... It's going. If we could get some momentum... This lock is still jamming. Like, look at that. It's jamming past into the logic. We're going to do a turn. There's a turn. That's... Oh, my God. The lag. What the heck exploded? Oh, the back pistons. We did a turn, though. 58 seconds. No, I don't want to reset. I want it to just... Can I see if it can get more momentum? I don't think it can. All right, I want to try it one more time. It obviously works. That's amazing. What I want to do is I just want to adjust these back piston lengths so that we're not, you know, permanently glitching it in. I think we need like 5 on this piston. Something like that. 8. That way we're not purposely, see now it's just snug. There we go. All right, let's see if we can do this faster. We can actually crank this on, and now it's torquing against an immovable object, and here we go. Right away it starts. It was 58 seconds before. I still think the timing's a little off on this. I feel like maybe it could be like 35, 25 degrees, like it's tweaked just a little bit. It's close, but basically you want like, you know, you want each piston activating as soon as it crosses the vertical line and then deactivating as soon as it crosses the vertical line on this side, right? Like if we look straight up and down. Man, that's actually pretty good though. I can't believe we're actually spinning the wheel. And like visibly spinning it, not just, you know, nonsense ratcheting it a tiny little piece at a time. I don't think we're gonna beat 58 seconds though. Here it comes. And this is the first torque challenge. I don't even know how we're gonna do the next torque challenge, honestly. I gotta make like a V8 or something. Maybe they'll give us 20 pistons or something like that. But I think after this, we'll go on to one of the other types challenges first, and then we'll come back to more torque once I've learned more things. 56 seconds, so pretty much the same deal. But yeah, let me know what you guys think in the comments down below. Wicked challenge. I want to build this again in creative and check it out and see what it can actually do with the torque test on the dyno, because I feel like it's right up there. A few things with the locks, definitely a good suggestion. The locks going from the unloaded side to the loaded side, that actually makes sense with how they work. I probably should use different blocks. I don't know, we don't really have much. We just have, you know, logic. Maybe we use those wedges and the bolts or something to actually prevent the clipping. I don't know, but something needs to change with the locks because they weren't really strong enough. And the timing, you know, I'd love to hear some advice about how to really tune your engines with timing, because I think this works better under this loaded condition. But the interesting thing is when you turn it on with that 30 degree, like you can visibly see the skip, right? So like obviously there's something wrong with the timing because of that skip, but like maybe 25, like negative 25. You know, it's hard to tell what's happening there. Amazing how fast this thing can rotate when it doesn't have a giant freaking wheel it's trying to spin. But yeah, let me know what you guys think in the comments down below. Definitely the most intense piston engine I've ever built. I could probably say, I think if I were to hook this up to the dyno, it's gonna have more torque than anything I've ever built. It's got the extra long arms. It's got, you know, out of any 4-piston engine anyway. I mean, maybe a 4-piston radial could have done it better. But yeah, let me know what you guys think in the comments down below. Make sure, of course, you hit that like button, hit that subscribe button. And if you have any other cool challenges you want me to try, let me know. I definitely want to do the piston speed challenge, but I think I want to play around in creative mode for a little bit and work on some engine timing things, because when we start to build fast engines, timing is going to be everything. And obviously we can use the trammel in the opposite direction to get, you know, a 2-to-1 speed gain on the output, but we're still going to need some fast piston engine mechanics. But let me know what you guys think, and as always, I hope you guys enjoyed this video, and we'll see y'all next time.